And today's topic is a very, very important and applicable, we'll talk about that, applicable subject of regression, linear regression and parabolic regression. And we'll explain that as we go forward in introducing this. So let's just jump into it. We'll go through a process of having data, having random pieces of data, and then being able to come up with an equation that is the best representation of the data that we have. And that representation can be in the form of a line. It could also be in the form of a parabola. It's called linear regression, parabolic regression. We'll talk about that more as we go forward with this process. Let's take a look. All right. So I've got this table here that we'll use to come up with our equations. All right. So let's say we've got some data. Excuse me. Let's say we've got a point 0, 100. All right. 0, 100. That might be at time 0, you have $100. Okay. So it's just data. That 0, 100 could be, like I said, time 0, you have $100. At time 0, you have 100 bacteria. So it's just data. It could represent a wide array of things. And then another piece of data you have at 150. At time 1, you have $50. And then you have another, let's call it a coordinate, 2, 100. 2, 100. And then you have another piece of data, let's say 3, 200. 3, 200. Okay? All right. So, what we want to do is show you how to come up with the best linear representation of this data that we have here. And what we're going to end up using is it's sort of an elaborate formula, but still it's a legitimate formula that if used, it can really give you some exciting results, exciting equation that's very, very applicable. And that equation, the form of a line, the equation of a line is y equals mx plus b. That's the slope-intercept form equation of a line. And the way we're going to get m with this data, the equation for m is equal to summation of xy, all right, minus the summation x summation y. This is divided by n. All of that is the numerator. All right, and then we have the summation of x squared minus the summation of x, all of that squared over n. Now that's a mouthful. That's a mouthful. But it's easy. It's a mouthful, but it's easy. All right? So now the y-intercept, that would give you the ability to solve for that variable there. The way you're going to solve for the y-intercept, or the variable b, is the summation of y minus the m that you calculated previously times the summation of x, all of that over n. All of that over n. All right? So it's a mouthful. However, I need my calculator. I'm going to need my calculator. This is a mouthful. However, it's not difficult at all. It's not difficult at all. All right, so let's just jump into it. Let's take a look. Let's just take a look at what we are doing. All right. So, the way we are going to go about substituting into this equation is we're going to really organize this data in a way where substituting into this is not difficult at all. And I think the best way to do it is just sort of go through the process, and if you have questions, you'll ask. You'll call in to the number 312-738-1060. All right, so this is x, this is y. X times y, you just multiply x times y. Here you get 0, and here x times y. In a minute I'll tell you why I'm multiplying x times y. But for now, just trust me that getting xy will be very, very helpful. xy for this point, 1 times 50, that's 50. xy for this coordinate, this point, is 200. 2 times 100 is 200. And xy for this point is 600. All right. x squared, 0 squared, that's 0. X squared for this value of x, that's 1. 1 squared is 1. Here, x is 2. 2 squared, that's 4. When x is 3, 3 squared, that's 9. Why we're doing this, we'll talk about that a little bit later. And I think what we're going to do is stop right there for now. All right? So now, excuse me, now what we're going to do is sum all of these up. Why we're doing this, we'll talk about that a little bit later. So the summation of x, that's what this symbol means. You take all of the x's and sum them together, that's 6. So this summation symbol here means add up all of the x values. I did that and I got 6. The summation of y, this summation means sum up all the y values. If I did that, I get 200, that's 450. 450. Let's sum up all of the products. All right, so I'm summing up the product of x, y. All right, so I've got x times y. I'm summing up all those products. I get, that's 800, that's 850. 850. And now, let's find the summation of the x squareds. All right, so if we do that, we get 14. Get 14. All right? So, why did we do that? Good question. Why did we calculate all this information? Why did I find the summation of x is 6? Why am I interested in the summation of y is 450? Why am I interested in the summation of a product or the summation of x squared? Well, it all has to do with what is necessary to solve for m and the y-intercept, the slope and the y-intercept. This equation requires the summation of xy. I have that right here. This equation requires a summation of x. I have that here. This equation requires a summation of y and so forth. Summation of x squared. I've got all that. Summation of y, summation of x squared. I've got it right there. All right, so the reason why I had to go through this organization of this data is because all of this information is necessary to substitute into the information that will give me the equation of my regression line. So this is my regression line equation. Regression line equation. All right. Regression line equation. All right. So let's begin to substitute into this equation. The summation of xy the summation of xy, I've got that right here. The summation of xy, I've got that right there. That is 850. All right? Minus the summation of x, I have that right here. That's 6. Times the summation of y, I have that right there. That's 450. Divided by n. N, I didn't tell you, but n is just the number of data points that you have. The number of data points that you have. And we had 4. I had 4 points. 1, 2, 3, 4. So n is 4. So that's all over 4. And now all of that is in the numerator. The summation of x squared, I've got 14, minus the summation of x, the summation of x squared. All right, so the summation of x was 6. So that 6 has to be squared. There is a difference between the summation of x squared and the summation of x. All right, so this was taking x squared and summing that, the square, summing a number of squares. What this means is taking the summation of x and then squaring it. The summation of x and then squaring it. So it's two different things. This is over 4. And now it's just a matter of completing this calculation. All right, so let's go ahead and do that. So we have 850. Move this to the side a little bit. So we have 850 minus, and I've got my calculator here. All right, so 850, and we have 450 times 6. We get 2,700. That's divided by 4. All of this is over 14 minus, this is 36 divided by 4, which is 9. All right, so now let's keep going. So we have 850 minus, take that 22,700, let's divide that by 4. You get 675, and that is over 5. All right, 675, so we get 850 minus 675, all right, and you get 175 divided by 5, and that is 35. Amen. 35. So the slope is 35. The slope of our regression line is 35. The slope of the line, if these points were plotted, well, I'll come back to summarizing all of this information a little bit later. Now we found the slope. We'll summarize all of this a little bit later. Now that we found the slope, let's find the y-intercept using this equation here. All right, let's find the y-intercept. So what we have, all right, so we have the summation of y. We have the summation of y, which is 450. 450 minus the slope, which we've already found. Uh-oh, running out of space here. We already found the slope. We found that slope to be 35, right there. So we have minus 35 times the summation of x. The summation of x, we have that already to be 6. The summation of x is 6. And all of this divided by n, which we said earlier was 4. All right, so let's keep going. So we have 450 minus 35 times 6. Get 210 divided by 4. All right. And 450 minus 210. 450 minus 210. That's 240. So we get 240 divided by 4. 240 divided by 4 is 60. The y-intercept is 60. The slope is 35. The y-intercept is 60. So the regression line equation is y equals mx plus b. Y equals mx plus b. Y is equal to our slope, our m, is 35x plus 60. That is the equation of the regression line. That is the equation of the regression line. Y is equal to 35x plus 60. Now, what is the significance of this? I'm glad you asked. I am glad you asked. How can this be beneficial? How can this be beneficial? Let's put together a little graph where we plot this information. All right? Let's plot this information. Let's set up a little graph here, and let's try to show you the value. Hopefully you can see the value in what we've done. All right. So let's call this the time axis. Let's call this time in years. Label that to be time in years, and then let's call this balance. This is a balance. That's money in dollars. Dollars. All right. U.S. dollars. All right. Let's show you how this can be beneficial. All right. So the data that we gave you, the data that we used to come up with this regression line equation was 0, 100. So at time z, let's call this 0 is 1. This is after 1 year, 2 years, 3 years, 4 years, 5 years. And this here is money. Let's say this is $50, $100. This is $150. $200. This is $300. Yeah, $250. I'm sorry about that. Let's say $250. Make that $250. 50, 100, 150, 200, 250, and then $300. All right? So, at time 0, you have, let's say in the bank, the data that I gave you earlier that produced this regression line equation was at time 0, you have $100. So let's plot a point right there. At time 0, you have $100. At time 1, you have $50. So for some reason, the amount of money went down that you have in the banking account. You have in your banking account. At time 2, you have $100. Right? And at time 3, you had $200. That's the data that that we're working with. All right. All right. Okay, so now what this equation provides you with is a line that best represents all of this data. All right, so if you were to graph this line, the y-intercept is about 60, and the slope is 35. So you maybe rise 35, run 1. This is a sort of a rough estimate. The line would look something like this. The line would look something like that. I'll make it dotted. I'll make it dotted. All right. So this is a rough estimate of what this best fit line looks like. All right, what this best fit line looks like. So what this provides you with is an equation that best represents all of this data. So let's say you want to, let's say this is the amount of money you made over the course of 3 years. Let's say your employer says to you, we're going to increase, or we anticipate the amount of money you make every single year to remain about the same, or the money that you make through your employer will continue to remain consistent in, let's say, a linear fashion. Your money is going to continue to grow in a form that's very, very similar to the way it's growing here. It's going to continue to progress the way this is progressing. The amount of money that you have is going to grow linearly. Well, what you can now do is use an equation to predict, or another word for predict would be extrapolate, how much money you're going to have 4 years from now, 5 years from now, 10 years from now. You can use this equation. You can use this equation. All right, so if you wanted to predict, this is, by the way, is your y-axis, x-axis. If you wanted to predict how much money you would make, let's say, 10 years from now, you could just put a 10 here. You could put a 10 here. All right, you could put in a 10 here, and you'd get 350 plus 60, multiply 35 times 10, you add 60, you get 350 plus 60 is $410. So 10 years from this time here, the amount of money would be $410. And that would be a very, very good estimate of the amount of money that you'd have 10 years from this time right here. Similarly, you could anticipate the amount of time it would take, given this equation, you could anticipate the amount of time it would take to have a certain amount of money. Let's say you want $500. Let's say you want $500. Well, because the y-axis represents the amount of money that you have, you could put $500 in for y. So you got y is equal to 35x plus 60, 35x plus 60. You could put $500 here, 35x plus 60. All right, and you could, to solve this equation, you would solve for x. You would get 440 by subtracting 60 on both sides is equal to 35x. You divide by 35 on both sides, you'd get 440 divided by 35, and you'd get 12.5. X is equal to 12.57. So what does that tell you? Given this data, if you wanted to predict how much time would it take for you to go from the initial amount that we had, which is $100, we had $100 at time 0, predict how much time, if you're assuming a linear relationship, how much time would it take for you to go from 100 to 500? Well, the amount of time would be 12.5 years, right? 12.5 years. So we tried to show you how this linear regression line could be very, very beneficial. very, very beneficial. All right. But another thing I'd like to share with you, is this does not necessarily have to be a linear relationship. This data could also, hopefully you can picture this data forming a parabolic, coming up with a more parabolic relationship between the data, in which case you would not want to come up with a linear regression linear equation, but more of a parabolic regression of the data. So let's spend the second part of the class. Going through more of a parabolic, coming up with a parabolic equation.